Hello, my dear students. Today I came in front of you with one more interesting topic called as circles. In the circles, all important formulas. In one video, all very important formulas I am going to explain to you. So watch the video till the end and try to remember all these formulas which will help you in exam when you are solving a question. Let's see, in this first important formula is, we all know in any circle tangent is perpendicular to the radius. Tangent is perpendicular to the radius. Then here OA will be called as distance between center and external point, and AP is what? Length of the tangent. OP is what? Radius of the circle. Then the relation between distance between center and external point, length of the tangent, and radius is, we can use Pythagoras theorem. So we can write here OA square is equal to OP square plus AP square. So now onwards you can remember it as a formula as B square is equal to R square plus L square. So you can use this formula now onwards whenever you want solve a problem related to these three. Very important for objective and sometimes for subjective also. Hope you understood how this formula has come and use this formula to solve, to find out any one of these three. Two will be given, you have to find out third. Now coming to this, here two concentric circles are given whose radius of larger circle is capital R and radius of smaller circle is small r. Then here again, we have a right angle triangle here, OAP. From this again what? We will be having Pythagoras theorem again. Then what we get here, AP square we get as capital R square minus small r square. I wrote directly. Actually, capital R square is equal to AP square plus small r square. From that, AP square is equal to capital R square minus small r square. Implies what happens? AP is equal to root of capital R square minus small r square. They will ask you to find out the length of the chord. How question will be given? Find the length of the, in two concentric circles, the chord of the bigger circle touching the smaller circle at point of contact P. Then find the length of the chord of the larger circle. Then what? We can find out using by this formula. AB is what? 2 times of AP. So AB is equal to 2 times of AP is what? Root of capital R square minus small r square. So here what happens? If you know radius of bigger circle and radius of smaller circle, then by using this formula directly you can find length of the chord. Hope you understood the second formula also. Now coming to third concept. Third concept is very simple. We have a proof by using RHS congruence rule. Like this, if you join this and join this also, we can prove these two triangles congruent by RHS congruence rule. How? OA is equal to OB, radius of the circle. OP is equal to OP common. So hypotenuse is equal and two pairs of sides are also equal. Then angles, right angles are also equal. So by RHS we can say that OAP is congruent to OBP. So by this what we can write? Important formula here. We can write down PA is equal to PB by CPCT. By CPCT we can write PA is equal to PB. Actually this is the theorem. You have to prove lengths of tangents drawn from an external point to the circle are equal, and you remember if two tangents are drawn from an external point, then lengths of tangents drawn from an external point to the circle are equal. So you can remember this also as a formula. So coming to here, this is what? A quadrilateral ABCD is circumscribing a circle. Okay, sides of the circle, sides of the quadrilateral ABCD is touching the circle at PQRS. Then if a quadrilateral circumscribes a circle, like ABCD is touching circle at PQRS, then what happens? Sum of opposite sides will be equal. So what we can remember? AB plus CD is equal to AD plus BC. This is a proof again. There will be formula and there will be proof to find out it. And I want to tell you only formula so that in exam if any question comes related to it, directly you can solve by using this formula. If it is objective or short answer type, you can do by using this formula. Try to remember. If a quadrilateral is circumscribing a circle, then sum of opposite sides are equal. AB plus CD is equal to AD plus BC. Try to remember it. Next one, coming to this, here what is happening? Here before quadrilateral is circumscribing a circle, now triangle is circumscribing a circle. If a triangle circumscribes a circle as shown in the figure, then what we can write? You take these alternative parts, like AP is one part plus PB you leave, then BR plus CR you leave, then CQ is equal to what happens? Half perimeter of triangle ABC. Try to remember this. Hope you understood this. I repeat again. So here what happens? If a triangle circumscribes a circle, such that sides of the triangle are touching the circle at PQR, then what happens? AP plus PB you leave BR plus CR you leave CQ is equal to, and it is also equal to one more value. What? We left no alternative values we left, so those we can write. PB is equal to, then CR I wrote is equal to PB plus CR plus AQ, alternative parts, and these both are equal to half perimeter of triangle ABC. Try to remember this, and this also one proof will be there, but if you remember it as a formula, you can use in objective or short answer type, and try to practice all these proofs also. If time is there, I will make one more video how to prove all this. Yeah, this is one important concept. And one more down, what is happening here? Triangle is not circumscribing the circle, but what? Externally, when you extend two sides of the triangle, they are touching the circle. So we can say it as exterior circle, X circle of the triangle. You can also see it as a X circle of a triangle, or we can see AP and AQ are the two tangents touching the circle at P and Q, and BC one more tangent which is touching the circle at R. Then what happens in this case? AP is equal to length of the tangent, AP is equal to, or AP is equal to, it is also equal to AQ because lengths of tangents are equal. AP is equal to AQ is equal to, both are equal to half perimeter of triangle ABC. Half perimeter of triangle ABC. This is also one important proof, and you have to remember it. So these are some concepts related to distances and distance, lengths. Now we will discuss some important concepts related to what? Angles. These are very important results or formulas to remember to solve objective type or some short answer type questions. If you want long answer type, they may ask you to prove those proofs also. If possible, we'll discuss in the next video. Now coming to angles related questions. important angles related questions, how they will ask in exam. First point, if PA and PB are the two tangents drawn from external point P, OA and OB are the radius, then one important concept is what? Angle APB plus angle AOB. Angle APB plus angle AOB is equal to 180 degrees. Why? Because we know angle OAB is 90 degrees, angle OBP is also 90 degrees. And we know sum of four angles in a triangle quadrilateral is 360 degrees. So if these two are 90, 90, 180, A and B, then O and P is also 180. AOB plus APB is also 180 degrees. Try to remember this point also. One important point. Now coming to next one. Here, yeah, this one also very important. Here what happens? First point, one relation between AOB and AQB. You know angle AOB, it is there in 9th class. Angle AOB is half of angle AQB. Sorry, I wrote in reverse way. So what it is? Angle AQB. Angle AQB is half of angle AOB. Angle made by the arc at the center is twice the angle made by the same arc at remaining part at any point on the remaining part of the circle. So here what? This is at the center and this is at remaining part of the circle. Then what happens? This angle will be half of this. So angle AQB is equal to half of angle AOB. This point we have to remember, as well as one more is what? You know, APBQ. APBQ is a cyclic quadrilateral. So if you know AQB, we can also find APB. And here one more relation what we can write between APB and AQB. Angle APB plus angle AQB is equal to 180 degrees. One more important relation, you have to remember this. So this is one point here to remember. This is one more point to remember. Try to remember these two points from this formula, from this diagram. Whenever diagram is given like this, try to remember these two. Now coming to here also one important concept only. So here what happens? Angle OAB will be, see I marked with red color. OAB will be half of APB. Angle OAB is half of angle APB. They ask you, they may give you it, what is APB? APB will be given. They may ask you what is OAB, or OAB will be given. They may be asking you APB. So you have to know the relation between these two. OAB is half of APB. These two opposite sides, this one and this one. Okay. Now similarly, one more result what you have to remember here. Angle PAB. Before we wrote OAB, now it is PAB. With white color I represented here. PAB, angle PAB, this angle. Angle PAB is half of angle OAB, this angle. This also you have to remember. Half of angle OAB. These two also you try to remember. Right. These two are important concepts here, important formula. Now here one more, last here formula number 11. In this, what is happening? Again, quadrilateral is circumscribing a circle. Before also we have seen when quadrilateral circumscribes a circle, opposite sides, sum of opposite sides, AB plus CD is equal to AD plus BC. Now here, related to angles, what? AOB and COD are supplementary angles. Opposite angles subtends supplementary angles at the center. Means what? Angle AOB plus angle COD will be equal to 180 degrees. So what we can write it as angle AOB plus angle COD is equal to 180 degrees. One formula. And similarly, one more is what? Angle AOD plus angle BOC is also 180 degrees. We have this proof, and they may ask you sometimes objective questions also based on this. So not only that proof, this result also you remember to solve short answer type and objective type questions. So these all are what? Some angle related problems. Similarly, we have some more results related to distances and angles and distances both. So here in this figure, if you see 12th formula, if angle AOB is given 60 degrees, angle AOB is given as 60 degrees, then what happens? You know, triangle AOB is an equilateral triangle. Remember this. Okay, if angle AOB is 60 degrees, what happens? These two angles are equal because it is already isosceles. Then these two angles also must be equal, so they will be 60, 60. So every angle is 60 degrees, it will become equilateral triangle. Then how sides will be? AO is equal to OB is equal to AB, and all will be equal to radius of the circle only. So if angle at the center is given R, then angle at center is given 60 degrees, then what happens? All the three sides, the triangle formed by the radii and chord will be equilateral triangle, and all the three sides are equal to radius of the circle. Hope you understood this concept. Now next one is what? I'll write it again. So better you take this screenshot to remember all these. Right, now coming to next one. In the previous one, 12th format, what we have seen? Angle at center is 60 degrees. Now, if angle at external point is 60 degrees, then this triangle becomes an equilateral triangle. So, if angle APB is 60 degrees, what happens if angle APB is 60 degrees? Then triangle APB will become equilateral triangle. Triangle APB is an equilateral triangle. Then what? We can write AP is equal to EB is equal to AB. It is not equal to radius now, but all the three sides are equal. So if you know length of the chord, that is also equal to length of the chord. If you know, that is also equal to length of the tangent. Length of the tangent and length of the chord are equal there. This is one. One more. Coming to here, if angle is 90 degrees, 14th one, angle at the center is 90 degrees, then automatically angle at external point will be 90 degrees because sum of them is 180 degrees. If angle at center is 90 degrees, P is also 90 degrees. P is 90 degrees, O is also 90 degrees. These two are 90, 90. Already we know A and B are 90, 90 because they are the angles between tangents and radius. So what? In this case, if angle APB is equal to 90 degrees or any one of these two, angle AOB is equal to 90 degrees. In these two, if any one of these two is 90 degrees, what happens? APBO will become a square. APBO will become square. In that case, what happens? AP, all the sides will be equal. AP is equal to PB is equal to OB is equal to OA is equal to R. All the sides will be equal, and all the sides will be equal to what? Radius of the circle. This is one important note here. And one more important note. You know, diagonals OP is equal to and AB is equal to root 2 times of R, because diagonal of a square is root 2 times of its side. So try to remember this point also. You want to solve objective quickly within less time. If you remember all these formulae, then you know saving time in solving objective is important. If all these points are there in the mind, you can do very quickly. So what is important point here? If angle is given 90 degrees either at external point or at the center, then that quadrilateral will become a square. Then all the sides will be equal to radius, and the diagonals OP and AB will be equal to root 2 times of radius. Now coming to last one, sometimes what happens? Sometimes they give you angle and radius. They ask you to find distance between O and P or the length A and B. Like that also they ask. So here what we can remember, if you know angle APB some theta, some angle it is, then radius OA is equal to OB is equal to radius is R. Then if they ask you OP, length of OP, they ask you OP, or if they ask you AP or OP, then what you have to do, if you want OP, sine theta by 2. If it is given only upper angle, that sine theta directly you can take. If it is given APB directly theta, then sine theta by 2 is equal to opposite side by hypotenuse. This is angle here theta by 2. Then this is what radius R, opposite side by hypotenuse. Hypotenuse is what? Here is 90 degrees. So the hypotenuse is OP. So what? That implies OP is equal to, or you can remember this formula, just remember this formula and then substitute in that, then we will get the value of OP from this. Just remember, when angle is given and radius is given, you have to use sine theta by 2 to find out OP. Similarly, if you want AP is what? Adjacent side to the angle, and radius is opposite side. In that case, what you have to use? Tan theta is equal to, tan theta by 2 is equal to, okay, opposite side is R again and adjacent side is AP. From this we can find the value of, just try to remember these two methods to follow to find out length of the tangent or distance between external point and center, then we'll get answer. One second. So it's over. I explained all the important concepts in circles. So these are some very, very important concepts where you feel difficult. If you don't remember, it takes very much time. It will not strike in the mind when you write exam. So try to remember all this. Hope this video will help to you. If you think my videos are helping you to learn something better, so like, share, subscribe and encourage me. Thank you.